Welcome to the farewell episode of Math 104 Final Exam Review. We're working on chapters 7 and 8 today. So we're going to warm up by evaluating some roots. You got the fifth root of -32. Make sure you can do those in your calculator. Get -2. Make sure you can do those higher index roots. Now for 8, here we've got matching index and exponent. And it's odd, so we get x. Don't need any absolute values there. That's just the even ones. And for the ones on the exam, I'm just going to assume that all the values are positive, so you don't need to worry about the absolute value. 30. So this one, we want to convert this to radical form, and we have a negative exponent. So first thing we're going to do is write this as 1 over 3 plus b to the 5/3 power. And then the last step there will be convert this to a radical. So that gives us 1 over the 3rd root of 3a plus b to the 5th power. All right, next up, we have 11 to the 6th power. All right, now with this one, we're going to write it in rational exponent form. And since we don't have an index here, it's implied to be 2. So the exponent goes on top, the index goes on the bottom. We have 11 to the 6/2 power. Well, 6 divided by 2 is 3. So that's 11 to the 3rd power, which is 1331. All right, next up, r to the 12th. And then we're going to take the 3rd root of that. So that's r to the 12 on top, 3 on the bottom, 12 over 3, or r to the 4th power. All right, now next one is just properties of exponents. So we have the same base, 96. Since we're dividing, subtract the exponents. 2/3 minus -1/3 is 1. So that is 96 to the 1st power, or just 96. Now for 39, we're going to simplify this expression. Usually the easiest way to do these is by simplifying inside the parentheses first. Don't worry about that until later. So let's do that. Using the properties of exponents, we can combine the exponentials with a z base. So we got -1 minus -1/2, which is -1/2. So we get z to the -1/2 power. Now we can do the x's. We have -3/5 and 1. So -3/5 minus 1 is x to the -8/5. So that combines the z's and the x's. We just have this 2 remaining down here. 2 to the -2 power. And then all of this is to the -1. Now what we could do here is do the fraction flip thing. But that doesn't help us as much as if we took this -1 power and applied it to each one of these individually. Because they're all negative, now they're all going to turn positive. -1 times -1/2, that's positive 1/2. So this is either 1/2 power, x to the 8/5 power, and this becomes 2 squared. So we have z to the 1/2, x to the 8/5 over 4. Next up, got number 44. Got a k to the 3rd, 4th root, k to the 3rd, 2nd root. And we're going to combine these. But we can't just combine them using the product property because we have different indices. So we're going to have to convert these to rational exponents first. exponent on top, index on the bottom, and then we're going to multiply by k to the 3/2 power. And now we can use properties of exponents. Except when we combine these, we're going to need a common denominator. So this will be k to the 3/4 times k to the 6/4, or 6/4. All right, so I just changed 3/4 or 3/2 to 6/4. And now we've got a common denominator. Now we can add the exponents. So we get k to the 9/4. Next up, 46. Same idea, but with division. So this is going to give us t to the 5/3 over t to the 1/6. Right now, before we subtract, if you do this in the calculator, you don't need a common denominator. So you can just, like up here, you can just do 3/4 minus 3/2. Convert that to a fraction in your calculator. I recommend doing that on the exam. It's much faster. But here, I'm just going to convert this to 10/6. So we got t to the 10/6, or t to the 1/6 power. All right, now we have a quotient. So we use the quotient property and subtract the exponents. So that's t to the 9/6 power. Now we can reduce fraction 9/6 and get t to the 3/2 power. Next up, number 48. So here we got double radicals. These look much worse than they are. Let's convert this to a rational exponent. All right, I'm going to keep the outside radical. And this becomes x to the 1/5 power. And now we'll just do it again. The third index, we can think of this being x to the 1/5 to the 1st power. So 1 goes on top, 3 goes on the bottom. Power to a power, multiply the exponents, and get x to the 1/15. All right, next up, we are going to start multiplying and simplifying. So here, we're going to use that product property and get square root of 5 power. Now, nothing inside here can be simplified, so we'll just leave it at that. So square root of 5 power is the answer there. All right, now with 75, we need to break this up into, we've got square roots, so we need a perfect square. And we need a perfect square that divides evenly into 75. So it's 25 and 3. So square root of 25 times the square root of 3. And that becomes, make sure I'm not going on the screen here. That becomes 5 square root of 3. Right, 58, third root of negative 108. Now, since we have a 3 index, now we're looking for perfect cubes. So we want a perfect cube that divides evenly into 108. And that is 27. And we can actually make that a negative 27. So I'll get rid of the negative. Well, it'll remove the negative from the radical. So it's third root of negative 27 and a third root of 4. Third root of negative 27 is 3. So we get, or negative 3. So we get negative 3 times the third root of 4. Next up, we'll do number 60. So with these, let's break these up into the perfect cube radical and the leftover radical. And we'll factor these into the perfect cube and leftovers. That's 64, that's nice. That's a perfect cube just by itself. So that one goes over here. Now, p to the fourth, we need the largest multiple of 3 that's less than 4, and that's 3. All right, we want all the variables in this one. We want the exponents to be multiples of 3. Now, if we have 3 of the 4 p's over here, that means we have 1 leftover p for the leftover radical. Now, q to the 6, that's already a multiple of 3. So I'll just put that in the left radical here. All right, now this thing, now we can simplify this, and it should remove the radical. So we get 4, take the exponent, divide by the index, get p, 6 divided by 3 is 2, q squared. And then third root p. Next up, 64. Now this one, what we can do is split up this radical, apply it individually to the numerator and denominator. So we get the third root of m to the 15, third root of 27, just using the quotient property. And then next up, 15 divided by 3 is 5. So we get m to the 5th, third root of 27 is 3. So that's m to the 5th over 3. $68. We're going to do the fourth root of p to the 6th. Converting to rational exponent form, exponent goes on top and x goes on the bottom. So it's p to the 6/4 power. Now we can reduce this fraction to 3/2. So now we can go back to radical form. And get the third root of p. Nope, I reversed that. Second root of, and that's not the answer. Second root of p to the 3rd power. All right, now it's not simplified because the exponent is greater than the index. So that means we're going to break this up into the square root of p squared times the square root of p. All right, just using the properties of exponents, break it up p to the 3rd and p squared times p. Now this just turns into p, square root of p squared is p, assuming that p is positive, and we'll assume that for all of these. And that gives us p times the square root of p. Next up, 70. Got the square root of x times the 5th root of x. All right, let's convert this to rational exponent form. So it gives it x to the 1/2 power times x to the 1/5 power. All right, now we're going to combine these. Now I'm just going to get a common denominator here of 10. So it gives us 5/10 and 2/10. Again, you can just do this in your calculator, just add them together and convert to a fraction. So now we can add these together and we get x to the 7/10. All right, we'll convert back then to radical form. 7 is the exponent. 10 is the index. So 10th root of x to the 7th power. Next up, we're going to jump to 82. So we can't combine these right now, because we don't have like terms. You've got square root of 80, square root of 45. They aren't the same. You can only add and subtract things that are the same. So we need to simplify these such that we get the same radical. Now this one can be simplified by splitting this up into a perfect square times something else that gives us 80. And those two numbers are 16 and 5. 16 is a perfect square. We can do the same thing over here. We break up 45 into 9 times 5. 9 is perfect square. And that gives us the matching radical square root of 5. And so this gives us 8 times 4 times the square root of 5 minus 3 times 3 times the square root of 5. So we got 32 square roots of 5 on the left minus 9 square roots of 5 on the right. All right, now we've got like terms. So we'll take 32, subtract 9 from that, and get 23 square roots of 5. $84. So you got 2 times the square root of 54, m to the 3rd power. That's 5 times square root of 96, m to the 3rd. All right, same game. We need perfect squares here. So I'm going to break this up into see, 9 will be a perfect square that divides into 54. And m squared is a perfect square. So 9m squared here. And 6m, those are the leftovers. And just to confirm, just make sure we got 9 times 6 is 54, m squared times m is m to the 3rd. All right, plus 5 times, I'll do the same thing over here. We're breaking up 96 into 16m squared and 6m. All right, now let's simplify these two radicals. So we have 2 times 3m times the square root of 6m plus 5 times 4m times the square root of 6m. We can combine these, that gives us 6m times the square root of 6m plus 20 n square root of 6n. Now finally we can add these together. All right, we got the like terms of square root of 6n. So we'll add these and get, I guess you could consider it to be like terms of n times the square root of 6n. So here are your like terms actually. Now we'll just add together the coefficients and get 26 and square root of 6n. All right, next up, 86. Right, -6 times the fourth root of 32 plus fourth root of 512. All right, so we're gonna have to break these up here. All right, I need a perfect quad, and that'd be 16. So I can break this up into the fourth root of 16 times the fourth root of 2. And that fourth root of 2. That fourth root of 2 is a clue for over here. So now let's try breaking this up into something times the fourth root of 2. So divide 512 by 2, and we get 2. Let's put 265. 256. There we go. Okay, now we can evaluate these perfect quads here. So -6 times 2 times the fourth root of 2 plus 16 fourth root of 256 is 4. So we got 4 times the fourth root of 2. I multiply these out. That's -12 times the fourth root of 2 plus 4 times the fourth root of 2. Now we have like terms. We find these and get -8 times the fourth root of 2. $88. All right, now we're multiplying binomials. This is the factored form of difference of squares, right? Same terms, different sign in the middle. So that means we just need to multiply first times first. Minus last times last. Now square root of 7 times square root of 7 is just 7. Square root of 5 times square root of 5 is 5. Subtract those and we get 2. $89. Now these we're gonna have to fill out. So we'll start here, first times first. 3 times 2 is 6. Square root of 2 times square root of 2 is 2. So there's a result of first times first. All right, now we'll do last Negative 3 times 3 is negative 9, so negative 9 square root of 2. Inside, 1 times 2 is 2, so plus 2 square root of 2. And then last, minus 3. So this is 12. Combine like terms here. Minus 7 square root of 2. Minus 3. And then finally combine these two and get 9 and minus 7 square root of 2. Next up, we're going to do 94. Our objective here is to rationalize. Rationalize the denominator. You can have no radicals in the denominator. If you want to get rid of a radical with a single number inside, just multiply it by itself. And then the denominator will turn into 2. Now on top, we'll have to multiply 3 times 2 to get 6. So we get negative 6, square roots of 6 over 2. And then we can simplify these two numbers. Negative 6 divided by 2 is negative 3. So that's negative 3 square roots of 6. $96. All right, square root of 11 over 8. Now we want to rationalize this because if we have a square root over the whole thing, then that's necessarily a square root in the denominator. Because we can always rewrite this as square root of 11 over the square root of 8. Now, one thing that's really helpful in this situation is to simplify first. We can break up that square root of 8 into square root of 4 times the square root of 2. Square root of 2. Square root of 4 is 2, so we get square root of 11 over 2 square roots of 2. All right, so we're almost there. We still have this radical here. It's fully simplified though, so all we have to do is multiply by the square root of 2 over the square root of 2. That'll remove that radical. Multiplying on top, we're going to combine these. So we get the square root of 22 over 2 times 2. All right, 2 times. Multiply these two together, we get another 2. And then finally, that gives us square root of 22 over 4. All right, 98. Now to rationalize something like this, keep in mind, if we want to move the radical, we need to have an exponent here that's a multiple of 3. That way it divides evenly and removes the radical. So we are going to first split this up. So we'll do third root of 108, m to the third power on top, and the third root of n to the fifth on the bottom. Right now, I need to make this a multiple of 3. So I need one more n. So I'm going to multiply by the third root of n over the third root of n. That way we combine these two since we have the same index. Combine them, use the properties of exponents to get n to the 6th. Meanwhile, I'll do that next time. All right, now third root of n to 6. Now this I can simplify. We're still going to need to simplify here though, as well. Now 27 divides evenly into 108. So this can be broken up into the third root of 27 m to the third power times the third root of 4. And we still have the third root of n. All of this over n to the 6/3 power. Let's converted this to rational exponent form. Exponent on top, index on the bottom. All right, now this thing simplifies. So we get 3m. And these we can combine. So third root of 4n all over n squared. Next up, 100. This is a little different because we've got a binomial in the denominator. So in order to simplify this, we're going to need to multiply by the conjugate. So remember, the conjugate is the same term, or the same, same terms, different sign. So we're going to multiply by square root of 6 plus 3 over the square root of 6 plus 3. Right, make sure you're familiar with the idea of the conjugate. It comes up all the time, especially with radicals and with complex numbers. All right, now we distribute -5 into the top. So it's -5 square root of 6 minus 15. Should I have done that? No, I should have done it. Let's not do that. Let's leave it in factored form. That'll make it easier to see if we're going to be able to simplify later. So leave it in factored form. Okay, now here we have factored form of difference of squares. That's the nice thing about using the conjugate is when we multiply these, we just go first times first. We get 6 minus last times last, which is 9. 6 minus 9. That is all over -3. Now we do have a cancellation. The negatives cancel. And you can leave that in factored form, that's fine. All right, 102. Now we're just trying to leave this one in the lowest term, so we have fraction. Put in the lowest term. So in order to be able to reduce this, we have to be able to pull a number out of this, factor it out, and then cancel the denominator. So 27, we'll write that as 9 and 3. 9 times 3. So we got a perfect square here in 9. All this over 6. So square root of 9 gives us 3, and now we can factor a 3 out of the top. And once I do that, I usually just write the denominators 3 times 2, and I can just see the cancellation there. So those 3's are going to cancel, leaving this thing. -6 plus the square root of 3 over 2. Next up, we're going to start solving some equations involving radicals. 104. Now, when solving equations with radicals, make sure you isolate the radical first. So you get this thing all by itself. I'm going to add 3 to both sides. Now, once we have the radical isolated, now we can square both sides. Now we'll get rid of the radical. So 2x minus 3 equals 9. Now we just got a regular linear equation to solve. So x is 6. Right now we need to check this answer because by squaring both sides, we may introduce extraneous solutions. This may not actually be the solution. So let's try it. Plug in 6 here. 2 times 6 is 12, minus 3 is 9. Square root of 9 is 3, 3 minus 3 is 0, so that works. X equals 6. One oh six. Now this one we got roots on both sides. Fortunately, they're not added or subtracted from anything. So we can just square both sides and that will remove both radicals at once. Now just make sure you remember to square both the 3 and the square root of x. So we're going to get 9x on the left. And on the right, the root and the radical will cancel and we get 10x minus 9. And we get x is 9. So let's check. Plug in 9 here. We get 90 minus 9 is 81. Square root of 81 is 9. So we get 9 on this side. Over here, square root of 9 is 3. 3 times 3 is 9. So that works. All right, 107. So same technique, we're going to square both sides. We'll have to FOIL over here. So this way, we can cancel, so we get x squared plus 3x plus 7. On the right, FOIL that to get x squared plus 4x plus 4. So we'll solve this now. Got x squareds on both sides of the equation. We'll subtract x squared from both sides. Those go away. All right, now we've got subtract 3x. That gets the x over here. Going to subtract 4 over here. And we add 3 equals x. All right, let's see if that works. Plug in 3 here. 9 plus 9 is 18. Plus 7 is 25. Square root of 25 is 5. 3 plus 2 is 5. So that works. X is 3. $109. This time we're working with an index of 3. So that means we have to raise both sides to the third power. Now, exponent rata and index will cancel, and we get 5x minus 1 equals 3x plus 2. There we go, x is 3 halves. I did that a little too quickly. Yeah, screwed up my sign there. Okay, let's do this over. There we go, that's better. X equals -1/2. All right, let's check. Plug in -1/2 here. It gives us -5 halves minus 1 is a -7 halves. Over here, we get -3 halves minus 2 is -7 halves. So that works. Next up, 116. All right, now I'm going to work with roots of negative numbers. So this is where I comes in. So the first step in all these, well, not always, but a lot of times, is to get that negative out, thrown underneath the radical, and turned into I. Now we just need to simplify it, square root of 200. So split that up into a perfect square. 100 is a perfect square. 100 times 2 is 200, so that works. And square root of 100 is 10, so that's 10i square root of 2. All right, 118. Now it says give answers in standard form. Yeah, whatever. I'm not that concerned about standard form. All right, so we're going to subtract this thing. So when we subtract, it's going to change the sign on both of those. So this is the same as 5 plus 4i plus 9 plus 3i. You don't have to do it this way. You can just combine them if you want. All right, 5 and 9, that's 14. And now we'll combine the i's, or this is combining like terms, or we can find the constants, then the I terms. So 14 plus 7i. All right, next up, we're going to do 120. Or with these, make sure you don't use the product property. That only applies to positive numbers. So we need to change these to positive numbers first. Right. Remove that negative, turn that into I times square root of 25 times I times square root of 81. Now we can evaluate both of these. So that's 5i times 9i. And multiply it out and we get 45i squared. Now I squared is -1. So that's 45 times -1, or negative 45. 122. We have two binomials multiplied, so we're going to FOIL. First, 2 times 1 is 2. Outside, negative 2i. Inside, plus 3i. Last, minus 3i squared. You can combine these two middle terms and then turn I squared into a negative 1. All right, so this will be negative 3 here when we multiply. Subtracting negative 3, don't lose one of the negatives. That's like adding 3, so 2 plus 3 is 5, so we get 5 plus I. Next up, 124. Now, in order to be simplified, we cannot have any i's in the denominator. So we're going to multiply by the conjugate, just like we did with radicals. It's the conjugate of the denominator, not the numerator. Now we'll have to FOIL on top. So first, we get 6. Outside, negative 3i. Inside, negative 2i. Last, plus I squared. All over. Here we got the factor form of difference of squares, so we'll do first times first. 4 minus I times I squared. All right, let's start simplifying here. That's going to be negative 1, that's going to be negative 1. They combine like terms in the middle. So 6 minus 5i plus negative 1 over 4 minus negative 1. All right, 6 plus negative 1 is 5, so that's 5 minus 5i on top over 5 on the bottom too. Now we can factor a 5 out of the top. So we get 5 times 1 minus I over 5. The 5's cancel, and we get 1 minus I. $126. I to the 36th power. All right, this is where we want to get I to the 4th power, because I to the 4th power is 1. So I'm going to use properties of exponents here to go I to the 4th to the 9. Right now we got power to a power. 4 times 9 is 36. So those two things are equivalent. Now I to the 4th is just 1, so we get 1 to the 9, or just 1. Next, 128. 128 is I to the negative 8 power. All right, negative exponent, that means it goes in the denominator. So that's 1 over I to the 8. All right, now I to the 8th is I to the 4th squared. Which is 1 over 1 squared, which is 1 over 1, which is 1. So another one just equals 1. That's it for the chapter 7 exercises. Got a few left here in 8. And we're going to solve some quadratic equations. So from 8.2, this is page 604, we're going to do number 10. Now we're given this quadratic. It's not in standard form. You need to get everything over to one side. And now we can pick out the values of A, B, and C. Right? Coefficient on the x squared term is 1, so A is 1, B is 5, C is -7. Now we've got the three values for the quadratic formula. So let's plug in there. A is B plus or minus square root of B squared minus 4AC over 2A. I'll plug in. So we have -5 B plus or minus 5 squared is 25 minus 4 times A, which is 1, times C, which is -7, all over 2 times 1. So this will be -28. So we're subtracting -28. Adding it to 25. So you get square root of 53. This cannot be simplified. 53 is a prime number. So that is our answer. -5 plus or minus square root of 53 over 2. Sometimes we get lucky like that. Number 12. X3 plus 3x plus 4 equals 0. We're already in standard form. There we go. A is 2, B is 3, C is 4. Let's plug in. So negative B, that'll be -3, plus or minus square root of 3 squared, which is 9, minus 4 times 2 times 4, all over 2 times 2. We got 1632. So 9 minus 32. That's -23 over 4. So now what we're going to need to do is simplify this thing. So we got the square root of negative. And it looks like since 23 is prime, that's going to do it. There's our two solutions. $14. So we need to do some work on this one to get it in a standard form. I'll distribute here. Now let's get everything over to the right. That'll keep the x term positive. Let these go away on the left. And on the right, we get x squared plus 7x plus 3. So we got 1 for A, 7 for B, and 3 for C. All right, now let's plug all these in. All right, negative B, so that's negative 7. B squared, that's 49. That's 4 times 4 times 3. All over 2 times 1. And 4 times 3 gives us 12, so 49 minus 12, that's going to be 37 over 2. Let's see, 37, that is prime. So that is going to do it. Negative 7 plus or minus the square root of 37 over 2. Just keep in mind, just get it in standard form first, pick out your A, B, C, and plug them in and simplify. All right, up next, we're going to talk about the determinant and what it says about the solution. So let's take a look at number 16. So standard form first, let's get everything off here to the left. I'm going to add 4 to both sides and subtract 3 from both sides. So A is 4, B is 4, and C is negative 3. So let's calculate the determinant. B squared minus 4AC, remember the radical is not in the determinant, it's just the thing underneath the radical. By B squared, that's 16 minus 4 times negative 3. All right, this will be 16 times 3, 48. It's negative, so we have 16 minus negative 48. So that is 64. So you have determinant of 64. So what does that tell us about the solutions? Well, first of all, it's positive. So we're going to have 2 real solutions. Second thing is, it is a perfect square. So that tells us we are going to have, or we're going to be able to solve it with the 0 factor property. So as it turns out, that means this is a factorable trinomial. We could factor it and solve it that way. And so we will have 2 rational numbers as our solutions. They will not be irrational because since the determinant is a perfect square, right? If we had 64 underneath here, the radical goes away because this turns into 8. So that's why a perfect square gives us 2 rational numbers. All right, let's do 17. All right, 4x squared equals 6x minus 8. Let's move everything off to the left. We'll subtract 6x from both sides and add 8 to both sides. All right, so A is 4, B is negative 6, and C is 8. So the determinant is B squared, negative 6 squared is positive 36. Minus 4 times 4 times 8. think I did the arithmetic correct there. All right, negative 92 for the determinant. Since it's a negative determinant always tells us we're going to have two complex answers. And whenever it's complex, then we're going to have to use the quadratic formula. And two complex solutions. So that concludes our mini-series Math 104 final exam review. Look out in the future for the sequel, Nightmare on College Algebra Street. Have a great day.